Hello and welcome back to module number 4. Today we are going to talk about probability theory, and I'm sure that all of us know about that, but we never thought about that in a sense of how can we make it a procedure that will help us to do that. In the end, I'm going to talk about base rule or law and what does it really means, but I want to start with the idea, what is it all about, what we are talking about when we are talking about uh, probability in experiment. What does it really means? So before we start, I would like to note that this module, I will not talk about the R. I will not refer to the R and not talk to the R. What I will do is give you reference to a textbook that is free to use, and it's called Introduction to Probability and Statistics Using R. Karen J. Cairns is a good friend of mine, and the website is the book is online for free. And so the idea here is again basic R concept in page 8, and how to apply that. You can follow that, and it will be quite easy. So back to our discussion and back to our things that we are looking at when we are talking about probability. One of the things that we are very keen about probability is the random experiment in an action or a process that lead to a several possible outcome. Example, when we flip a coin or a course grade. All those are part of experiment and part of what we are trying to approach. We have different approaches to assign probability. We have a classical approach, we have relative frequency approach, and we have subjective. I will start with the subjective. That is basically on a subject of assignment. We think that if we are looking at who is going to be the Super Bowl, the winner of the Super Bowl, it is our own subjective opinion, and we cannot apply probability to support our outcome. In comparison, classical approach is the ability that we can make certain assumption, such as equally or likely or independence about the situation. And I will give you a reference in 2 seconds in the next slide. Relative frequency is the idea of what is the frequency that this probability occur. It can be in the context of historical data, or we can see it in our own experience. And so those are the 3 classical outcomes when we are trying to achieve it. The classical approach, or the idea of the basic of probability, is that if the experiment has n possible outcomes, all likely to occur, this method would assign probability of 1 divided by n to the outcome. Example, if we roll a die and the die has 6 faces, 1 to 6, each of those sample occurs of 1 to 6 occurrence. So we have some idea what it is measured here in order for us to assess the probability. What about random selecting students in observing gender? Example, students can be female or male, and we can decide how we sort that out. So all those things considered to be the classical approach. And the classical approach is basically the idea that we saw that, we count that in order for us to do that. So the rolling 2 dice and summarizing 2 numbers on top. And so the sample space is the container, what is this experiment contain, and the probability, and each one of them has their assertment of the probability. In P2, it's 1 divided by 36. In P7, it's 6 divided by 36. As you can see, Each result has the idea of how we measure things with regard to it. Relative frequency approach is a little bit different. And so the idea here, and I'll give you an example of Computer Shop track the number of desktop computer system it sells over a month. And in this example, 10 days, it sold 2 desktop. So we can conduct or construct an estimate probability of event based on it. So the idea here is that every day we have days number of desktop sold, the number of days, and we have the ability to estimate that with that regard. So 1 divided by 30 is the first day. 2 divided by 30 is the second day. So it's more the idea of frequency, using frequency and the occurrence of the frequency in the data set that give us the idea of how to estimate the probability. And as I said, subjective probability is the idea that, example, your own judgment, your own degree of judgment of how to do that. The probability example, subjective probability, is your girlfriend or your boyfriend will say yes when you ask her or him to marry you. So this is a subjective. But in probability, we have additional elements, which is the probability of event, which is the idea of the sum of the probability of a simple event that constitute that event. Example, assuming a third die. So we have the probability, what is P1 equal to, and when we combine them together, we have the idea what does it stand for. So we have, in this case, we have the experiment, toss a coin twice, and we have the space, the possible outcome of the experiment, and we have an event. Each event is the subject of possible outcomes, in this case H and H, T and H, etc. And we have the probability of event, a number of assigned to the event. In this case, is it bigger than 0 or small or equal to 0? And everything is to be assigned to. So the basic concept, the experiment is the process by which the observation is obtained. An event is the outcome of the experiment, which is usually it's denoted by a capital letter. So the basic element to which it applies. And when the experiment is performed, a particular event needs to happen or does not need to happen. It depends. It's not strict rule that if you have an event, the outcome is already known. So an event cannot be disposed. It's called a simple event, and it's devoted by the E with a subscript. Each sample event will be assigned as a probability, how often it will occur. And it is usually the set of the sample events of the experiment is called sample space and devoted by S. So again, simple event and sample event. And I think this example gives you the idea what is a sample space and what is the simple event. So event is a collection of one or more simple events, and the idea is the odd number or the number minus 2. Again, how do you call it? How do you account for it? And how do you do with that idea? So using a simple event, the probability of event is equal to the sum of probabilities of the sample event contain A. If the sample events is experiment are equally likely, you can calculate it based on n multiplied by n, divided by capital N. So the number of simple events in A divided by the total number of simple events. So let's take the idea of toss a coin twice. What is the probability of observing at least one head? So we have the idea what is it means. But we have to take into account all other options. So again, this is what the counting and what is the probability when we console that and try to predict what is the probability of the outcome. But life is not as simple as that. We have also mutually exclusive events. So events are mutually exclusive if they cannot happen at the same time. So, for example, if we toss a coin, either head or tail might turn up, but not heads and not tails at the same time. So that's what we are calling mutually exclusive event. So we can only have one number show at the top face, and the number of the face are mutually exclusive events. How do we calculate that? Is that if A and B are mutually exclusive events, then the probability of A occurring or the probability of B is formulated by the following: B or A equal the probability of A plus the probability of B. This is easy. This is something that we probably already thought about. But what about joint event? For event A and B to be joint events, then the probability that both events can happen. So in this case, what the probability of A and B? So in this case, we multiply the probability of A multiplied by the probability of B in order for it to declare if it's independent of or not. But if the two events are independent, in case of one multiplied by the other, a set of events is independent in case of how we phrase it, how we measure it. So in this case, drug test, and then we have women, and B is the drug fails. Will event B, A will be independent of the event B? In this case, we are going to toss a coin, and in this case, we will see what if there is the independent and what is the dependent in that case. So those are the cases that we're going to need to be considered when we are counting on the probability. Another thing that we need to consider and to be aware of is the conditional probability of B given the A. And in this case, it's phrased that B divided by A is equal to A and B divided by A. So in this case, drug test, what is the probability of probability B divided by A? And what is the probability of A divided by B? So given A is dependent from B, what is the relationship between A divided by B and divided by A? So the conditional dependence is that events A and B are conditional dependence given C is the case. So in this case, we are adding the element of C into the equation in order for us to measure if it is the conditional independent in the given case of C. So an example, again, this is an example of it. This is how we phrase it, and this is how we apply it in order for us to do that. So A and B are independent, and they are conditional independent in both cases. Multiplication rule. So if two events, A and B, the probability that both A and B occur is the following formula. And I know that you're probably scared and that what does it really means and how we apply that. We will look at that. We will apply that, and I hope my examples will be clear and my assignment will be clear, so you will have better sense. So in the idea of this rule is that the probability of A and the probability of B given that A occur, it is equal to the following: A multiplied by B divided by A. So again, if the event A and B are independent, then the probability of both A and B occur is the following formula. An example: in a certain population, 10% of the population can be classified as being high risk of heart attack. 3 people are randomly selected from this population. What is the probability that exactly one of the 3 are in high risk? So the idea here is exactly one of the high risk, and this is the formula that we need to follow. And the idea here is this is what we can do in order for us to calculate that. I hope it makes sense. This is how I came up with it. This is how I display it. And please, if it's not clear, please ask questions. Additional rule is provide a way to compute the probability of event A or B, or both A and B. So that is the idea that the union of A and B. So this is the formula: A or B, it is A plus B minus A multiplied by B. So what is the idea? What is it sum up? How to apply that? Let's do some rule or some ideas of it. So the idea here is that we have the probability of A1, A2, B1, and B2. And the idea here is that in this case, A1 is 0.4. The probability of B1 is 0.7. So again, we add them up together in order for us to estimate that in additional rule, the probability is 0.46. I hope it makes sense. I want you to refer to our textbooks in order for you to complete this understanding, because in the past, this is something that people had to have the text in front of them in order for them to understand. Additional rule for mutually exclusive event. If and A and B are mutually exclusive, the occurrence of one event makes the other impossible. That means that if A and B is equal to A multiplied by B is equal 0. So the additional rule for mutually exclusive events is that if A or B is equal to A plus B, only if A and B are mutually exclusive. So let's take an example. In large city, 2 newspapers are published, the Sun and the Post. And if we will take their circulation, 22% of the city household have subscription to the Sun, and 35% has a subscription to the Post. A survey revealed that 6% of all households have both newspapers. So the idea of this type of question: what proportion of the city household describe to either newspaper? So what does it really mean? That we will take Sun or the Post, we will say Sun subscription plus the Post subscription minus the Sun and the Post, and it will be equal in the end to 0.51. So this is how I will be able to find the probability. So I want to outline what I'm going to talk about next. And this is important concept in probability and the Bayes rule or theory, and the random variable and the distribution. And now we are coming into the idea of a little bit more complex. I do understand that, but I will try my best here to simplify and to give you an example of a rainy day and the grass is wet in order for you to illustrate the idea of Bayes' rule. So, given two events, A and B, and suppose that A is bigger than 0, then what we have is the idea of A and B divided by A, and we will sort it out. So, if it is it is rainy today, and the grass is wet. And so the idea here is that we are trying to figure out if it was raining, is the effect on the grass. So the idea here is that we have what we are calling interference, with the one affect the other, and this is what we are trying to figure or trying to calculate in order for us to see if there is association with it. So in this case, if we have hypothesis or a statement about if it's rain, it has to influence the grass, and we have evidence to support that, that will be part of our equation when we apply to it. So in this case, this is what we do in order for us to prove that, in order for us to apply the rule, in order for us to do that. So we have priority knowledge, and we have the idea, the likelihood, and sorry, I jump ahead, and we have the post in order for us to make this interference or to understand if there is a relationship between them. We also have a more complicated forms of it and how to apply to it. I hope it will make sense. I know that the textbook, my textbook, cover that, and also the textbook that I will give you to read about that will give you more insight to it, because this is important, because we will use it further on in our class in order for us to apply. So this is a more complicated example. We have three conditions. It rains, the grass is wet, and people brings umbrella. So in the form of it, we have the formula that we can apply, and we can ask ourselves if the U, which is the people bring umbrella, divided by the grass is wet, what is the idea of it rains? And so this is what I want you to remember from it. We will continue it next time. I hope you enjoy it. This is just the introduction to probability. I will make more summary of that. You will have a little bit of exercise on probability. I hope it will make more sense. And then I will assign you some reading. So that's it for today. I'd like to wish you happy New Year or Rosh Hashanah, and I'll see you next week. Until then, have a good week. Bye.